Hello. This is an example of a DC nodal analysis analytical question of level 2. So let's get started. First, overlooking the circuit. Looks like we have a total of 6 nodes. We have 5 labeled potentials, V1 through V5, and then a ground node. And then we're asked to compute the power dissipated by the resistor highlighted in gray. So power dissipated by R4. So first, we got to determine how many equations we're going to need for this one. And it looks like we're going to need 5. So we don't have any control variables. We take the total number of nodes and subtract the reference node, which is 6 minus 1. So we're going to have 5. Perfect. First step would be to look to see if there's any voltage sources, and it looks like we have one roughly in the bottom right of the circuit, V1. And that's connected to V2 and the reference node. So V1 equals positive terminals on the bottom. So the reference node's potential minus V2's potential. In other words, 0 minus V2. In other words, just V2. So V1 equals negative V2. I don't see any other voltage sources, so let's just move on to, let's go to V1 at the top here and do some KCL work. To start, we have I1, which is a current source going out of the node, so it's going to be positive. I1 plus, let's find the current going across R2 from V1 to V5. Using Ohm's law, voltage divided by resistance. We have V1 minus V5 over R2. Next, we have the current going through R1 from V1 to V3. So we have V1 minus V3 over R1. Set that all equal to 0. Excuse me. We already worked with V2, so let's go to V3. And we have another current source going out of that node at the bottom. Its value is I2, and since it's going out of the node, it's going to be positive. I2 plus, let's find the current across R1 on the top from V3 to V1. Using Ohm's law, we know that's going to be V3 minus V1 over R1. Next, let's go find the current from V3 to V5 over R3. Again, using Ohm's law, it's going to be V3 minus V5 over R3. And that's it for that one. Set it all equal to 0. Let's move on to V4, which is kind of in the middle there on the right. Let's find the current going from V4 to V2 over the R4 resistor. So it's going to be V4, let's get a fraction in there, V4 minus V2 over R4. We're going to add that with the current going from V4 to V5 over R5. So same thing, V4 minus V5 over R5. And that's it for that node. So now finally, for the last equation, let's work with V5. For this one, we have a current source in there, and it's I2 on the bottom, and it's going into the node. And any current going into the node, we're going to treat that with a negative. So it's going to be negative I2. And then now let's use Ohm's law on the rest of the resistors. So starting from the bottom, from V5 to the reference node over R6, it's going to be V5 minus 0 over R6. We can ignore the 0. It's going to be V5 over R6. I'm going to add that with the current going from V5 to V4 over R5. So that's going to be V5 minus V4 over R5. Going to add that to the current going through R2 from V5 to V1. So V5 minus V1 over R2. And then finally, we have the current going from V5 to V3 over R3. So we're going to have V5 minus V3 over R3 equals 0. I should submit that. Perfect. All right, now I got to compute the SOT variables. And that is V naught and the power dissipated by the resistor. Let's start with V naught. And that's over on the left-hand side, kind of in the middle. And it's the voltage across R3 with the positive end on the left, negative on the right. So V naught is going to equal the potential on the left minus potential on the right, and that is V3 minus V5. Sweet. Now let's work with the power dissipated across the resistor, and believe that's going to be, here, let's double check the webbook. I like having the webbook open while I'm doing homework. Power dissipated by resistor can be found by computing the voltage across the resistor and using power equals voltage across the resistor over the resistance. So here, it's going to be voltage across the resistor divided by the resistance. Voltage across it squared divided by the resistance. And since it's squared, doesn't matter what order we do them, so let's do V4 minus V2 squared over R4. So V4 minus V2 squared. Over R4. And let's go ahead and submit that. Perfect, all done. And thanks for watching. I hope this helps.